We just completed the design of the enclosure of a very, very important system. This is an emission monitoring system. The same system can be used for microclimate data acquisition. Climate action is one of is high on the SDGs as well, so you can monitor your climate as well. And then it can be used for also meteorological purposes, maybe climate, for example. And also other ministries are in charge of environment as well. So we just completed the design of this using SolidWorks. And then this is a 3D printer over here. We use a 3D printer, so you can see. So these are other parts we have already printed. After several trials, we were able to come up with this final product. So as you can see here, this is Stevenson enclosure. So this is where all the sensors will be. Various gas sensors like sulfur dioxide, nitrogen oxide, carbon monoxide, volatile organic compounds, and so on and so forth. So this is very, very important for monitoring the operations of heavy industries like the international oil companies, cement factories, and so on and so forth. So the big question is set environmental standards, are they adhering to it or not? Secondly is that how do you remotely monitor some of these operations? So this actually solves such problems. So it's a multi-purpose system here, both your environment, as I mentioned, climate, and also emission. So it can be deployed anywhere. So uses it's going to be using solar panel at the end of the day. So I have to show actually the solar panel here. So this very solar panel will be on top here at the end. So you can see it becomes an energy autonomous system. It's still a work in progress. So let me open up the casing. So here's the top cover. So you can see a lithium iron phosphate battery. And then this is electronic the brain, which will be inside the top cover. And data now will be streamed to an IoT platform, or what we call the AI platform. So you can have data insights, visualize whatever is happening remotely. And I'm very, very excited. I can't really wait for this to be deployed. So you can also monitor luminous intensity. You can see there's a hole here. So it can tell you how much light. Everything to do with the environment can be monitored from here. And then made in Nigeria as well. And then after several trials with some of the interns here in TD4Pi, actually did a very good job as well. So this is basically ready and it can be replicated across the board. Now, additive technology is very, very important. To be frank, I'm amazed at this technology of 3D printing. In the past, we have to struggle with casing for our electronics, but thanks to 3D printer, we're able to do our own design, customize it to fit into all our, boards or printed circuit boards. So, the sky is just the beginning now. And again, we can actually, we'll have the modular approach here. So printed various objects. So I can decide to extend this enclosure here. This module. So you can see this module can actually have some sensors, like your gas sensors. And this prevents water from splashing into the sensors, as you can see that. I can decide to also even increase it further if I want. Increase the length, look at that. So that's our design modular. So it gives us that flexibility to deploy various solutions in various areas. So you're welcome to visit us at TD4Pi. Thank you very much. Take care.